Hello and welcome to this screencast introducing exponential growth and decay. While some quantities change at a constant rate and can be represented by linear functions, and others change at varying rates that lead to periodic functions that both increase and decrease, like sine functions, still others exhibit patterns that we quantify in different ways. One particularly important trend is functions that increase or decrease at a rate that is proportionate to the output of the function. One example of these functions arises in the application of how money grows with compound interest. Such functions are called exponential and have a natural algebraic form that we can work to understand. Namely, f of t equals ab raised to the t power, where a and b are positive real numbers and b is not equal to 1. In this section, you'll learn that every exponential function has the consistent property that it either always increases or always decreases. In addition, you'll find that, by definition, an exponential function's rate of change always itself changes in a constant way. For example, one class of exponential functions always decrease and always decrease at an increasing rate. Exponential functions also lead us to think about long-term behavior. What do we expect the output of the function to do as the input continues to increase without bound? In the near future, we'll see how these functions find important applications in modeling phenomena, such as how a cup of coffee cools as time goes on. In this section, we'll focus on basic exponential functions and their properties, including their domain and range, and the key factor that impacts how rapidly the function increases or decreases.